Leopard. Leopard, Light Intensity Experiment with On-Orbit Positioning and Satellite Ranging Demonstration, is a nanosatellite developed by Kyushu Institute of Technology, Kyutech, earlier abbreviated to KIT, and Nanyang Technological University, NTU, which will demonstrate multiple technologies including multispectral cameras to monitoring horizon glow, and onboard processing of one-way radio signals. The satellite was developed by students from 17 countries. The satellite size is 10 to 30 centimeters, or a 3U size CubeSat. Leopard was launched on October 26, 2025 on a H3-24W Launch Vehicle, and will be carried to the International Space Station, ISS, on board HTV-X1. Leopard will be deployed from the ISS's Kibō module. Mission. Following its deployment from the ISS, Leopard will conduct several technology demonstration missions. The satellite will deploy solar panels using shape memory alloy, SMA, and a heating system. SMAs were selected for use instead of traditional springs in order to create a thin deployment mechanism. Nanyang Technological University in Singapore developed Leopard's Single Event Latch-Up, SEL, mission payload, which will monitor ionizing space radiation. Space radiation can interact with electronic on-board spacecrafts and cause them to malfunction, a phenomenon known as single-event effects. Leopard's SEL mission payload consists of two microcontrollers with identical functions, one using radiation-hardened microchips, and one using commercial off-the-shelf, COTS, components. MSC. Leopard's multispectral camera mission, or MSC, will photograph Earth's atmosphere when the Sun is below the horizon, to observe Rayleigh scattering and aerosol scattering. The MSC payload has an RGB camera. A camera captures visible light using a color filter array to create full-color images by recording red, green, and blue light, and a near-infrared (NIR) (IR-IN) camera. Leopard will use its attitude control system to point the cameras while conducting an observation. Opera. Opera, Onboard Processing of Earth Origin One-Way Radio Ranging Signal, is a technology demonstration mission that will determine the satellite's orbit without the use of Global Navigation Satellite System, GNSS, such as the Global Positioning System, GPS. Multiple Earth-based parabolic antennae of a few meters size and synchronized with one another, will send signals to the satellite in S-band. The signals will be sent in a predetermined time epoch. The satellite will then track the time the signals arrived, along with the Doppler shift of the signals it received. From the difference in the relative time delay in receiving the signals, Opera will estimate its own position in orbit. Opera is expected to be able to position the satellite with an accuracy of few kilometers. The Opera device occupies 0.5 U of volume in the satellite.